Hello guys, welcome to Cafero at Simplify. So we are now looking at maximizing and minimizing of a function. And here we are going to look at this, that for relative maximum, when we differentiate the first time, we equate to 0. Then we differentiate the second time and to find out is it a maximum, is it a minimum. And when we differentiate the second time, this should, whenever the second derivative, when we said second derivative, it means we are differentiating the second time. Whenever the second derivative is less than 0, then it is a maximum. That means if you are to draw the curve, it will be like this, bending downwards, and so the total point will be up on the curve. So then for the second derivative, when the second derivative is greater than 0, that means it is a relative minimum, and the curve will always be bending like this. So do it yourself is here 11. Do it yourself here. We are having TR equals to 24Q minus this, the way it is. Why I prefer this? Because it is the only way I can write it on the computer and it comes out very well. But guys, after this, try it yourself on the paper, because personally I have done these things on the paper. Yeah, just to be proving your answers. So the question says find the relative maximum or minimum for the following positive function. So we have our TR equals to this. So the first time we are going to differentiate. When you differentiate this is a constant, it becomes 0. This is linear, it becomes 24. This one drops power rule, it becomes negative 11. This 3 drops and 3 cancels with 3 and you get q squared. That is what we are having here, 24 minus 11q plus q squared. Now, the second step, to find critical point, set the derivative mr equals to 0. So now this whole mr we equate to 0. What are we doing at this point? We are finding the critical points. So when we equate this to b equals to 0, you realize that this is a quadratic equation. So you rearrange it. You start with this squared minus 11q plus this. When you rearrange sort of that quadratically and you see what you get, I think you guys you still remember how to solve such equations. Or if you don't know how to solve this and don't want to give yourself a time, put it in the calculator. But I try to go through it. Here you put b squared negative b squared plus or minus, b negative b plus or minus b squared minus 4. A is this coefficient, then c out of 2a, which is 1. Yeah, so this one, you guys, you all know that. So when you put it on the calculator, or you can reach up to me and I show you how to put it in the calculator, you get two values of q. You get 8 and 3. When you get those values of 3, now we're saying find the second derivative. Second derivative of this, because the first time we differentiated, we got mr. So now we're differentiating only this. You realize this is a constant. This one becomes negative 11 plus 2q. And that is what we are actually having here when we apply the second derivative, negative 11 plus 2q. So now we're saying apply the second derivative test. What are we meaning? Use these points we are having 8 and 3 to fit in this, place them inside. So we have negative 11 plus 2, where there is q put 3, you get a negative 5. Where there is q put 8, you get 5. So come back to our rules. When our second derivative is less than 0, like at this negative 5 is less than 0, this means that this point is a maximum. And since this one will automatically be minimum, relative minimum, because the second derivative is greater than 0, it is giving us a 5.